CCA. So we are going to use the same data last time we analyzed the PCA. So now this time I will use the last project because the data is already here. So I will show you the second way how we can use different parameters. So this one we already did last time. So this is PCA. So the next step, you can use the same data by using by uploading in the Kineko last time we did. But if your purpose is to use the same data, so you don't need to go you don't need to analyze the whole thing. So just you need to go here, new means the data is same but the analysis will be different. So you have to go here. Yes, so the parameters, these two are same as we previously used. So the next one is it's up to you if your purpose is to use only one, but our purpose is to use the same parameter. So the next, so the if you think that your main data is this one and this one, it's up to you. But in our case, the main data is item. We are going to know the influence of environmental variables on the bacterial community or composition. So this one is our main data. So the next step is next. Sorry, I think I need to go. Yeah, this one. So here you can see that this is just the constraint. The last time we did the unconstrained analysis, the PCA, but this time we are going to use the constraint analysis. So there are different approaches you can use, but now we are going to use to show the similarity or dissimilarity, or we can say that the impact of environmental factors on the phylum. So the constraint analysis for this time we are going to use this one. So then finish. So it's up to you. Use the explanatory variable means these are environmental factors. Suppose we are using two. It's up to you which one you have to use. Next one is constraint analysis, RDA or CCA. It's up to you which one you have to use. But you need to understand what is difference between RDA and CCA. Last time I mentioned this one. This is the RDA is related to linear relationship, and this is unimodal. It means that RDA is in which the environmental parameters is directly proportional to the effect of environmental parameter is direct on the microbial community is directly proportional. So if this one, I already explained these two. So I think this time you can use the same the default setting. So the next, we are going to use the all constraint axis. Is if your purpose is to use the first constraint, it's up to you. But right now we are going to use the all axis generated during this. So the next, I think the last time we I mentioned this one last time. So there are different transformation analysis. So you want to know the number of phylum, you want to know the log fold diffraction or N2 Shannon binary index, it's up to you. So this time we also use the number of value. Last time we used the sample plot. So this time we are going to use the color code. Let's see what will be the result. Yeah, this one. So this one last time I already explained, so no need to use this one. Just see this one. So we only use two environmental factors, the nickel and chromium. These are almost the same as like the PCA, but the result will be different because the ordination method is different. Might be in case of PCA, this one will be here and the chromium will be here, but you need to consider which ordination you are going to use. So this is same. Here we cannot see the same because this is biplot. So only two parameters like bacterial community and the environment parameters are mentioned here. If you want to use the triplot, then definitely you will see the sites as well. If your purpose is just to know the distribution of grouping of sample or distribution of anything, so sometimes you can use the scatter plot against the plot like this. Here you can group the which sampling belongs to each other, similar to each other. So it's up to you. Biplot we already did this one, but right now we are considering this one. So the second one was like this one. So yesterday I showed you the different one. So in which here the size is constant, even though, but in this even the size is constant, but they differentiate the phylum richness on the by using the color code. If the color code is 9, the blue, then we can say that in this area number of phylum is 8. Even though it's like this one, the circle size is same, but the number of phylum in this specific site is only 2. So just this is color gradient, and the last one is, I think, I forget the name. But you need to know that if the size of the circle is small, then the phylum or genus or species richness is low. If the size of circle is bigger, then we can say that in this site species richness or phylum richness or genus richness is higher. So it's up to you which one you have to use. So here they have mentioned that the arrow represent the environmental variables. In the plot, this one the plot, and the different color represents the phylum cones or phylum richness. So it's almost same. But one thing you need to know about this one. So last time we did the unconstrained analysis, but this time we did the constrained analysis. So when you practice by yourself and you generated two figures, one is constrained, one is unconstrained, even though the data is same, so you can see that the what is difference. So on the basis of this difference, you can use any one of these ordination, either PCA, RDA, CCA. So it all depends on your data. So the second thing is mention, like suppose if you are not going to include the chemical analysis, just exclude this one and go here, and so there are many others analysis. It's up to you which one you have to use. So suppose we are going to use the PCOA, but remember, sometimes your data is not according to the ordinations. So in that case, you will not get the plot. So you will just only get the table, not the data, if the data is not according to this one. So for PCA, it's up to you which PCA is mostly based on similarity and dissimilarity distribution. So it's up to you which, it depends on your study which kind of diversity index you have to use. So bright, purest, distance, and other mostly here. So for time being, we are using this one. Yeah, this one. So even though, but in this case, we excluded the environmental factors. So it's up to you which one we have to use. So if your purpose is to compare both, so you can use both from here, these two, and go here and then use anyone. But in the last one, in this figure, we only use the only one, not the chemical analysis. If your purpose is used to include these two, so go here and do. And these are the same. I just explained this one here. So the next one, I think let me show another thing. Yeah, it's almost same. For constraint analysis, you can use both CCA or CCA and RDA. Anyone is okay. But when you are going to explain the result, the meaning of this figure, so that will be different, because one is constrained and another one is unconstrained. So the definitely this the even though the data same, but their arrows and their distribution will be different. So you need to keep in mind these things. And the second thing, this, do I need to let me? So this time we learned the PCA, we learned the RDA and the PCOA. So the explanation you have to learn from. The other things are same. Suppose this one, the bacteria, the name is not completed, you need to do manually. So at level, and this bacteroids, same like the previous one. Till now, mostly till now we don't know how to put all the names and the names included in this figure. Suppose let me show you this one. So one thing before, remember this one. Last time we confused about this one. So this one is before going to upload the Excel file, you need to reduce the name of your sample. So if the sample name contains more than more than 8 character, you need to reduce to differentiate to differentiate two same thing, two different things. Suppose in this case, this one is control R, but we don't know this control R is either control R. In this way it's okay. But sometimes, suppose like this one, we don't know is July or June. So the only 1, 2, 3, 4, 5, 6, 7, 8. So you need to reduce your the sample name. Later you can change here. It's up to you. You can change everything from here. You can give the real number of real name of this sample, but at the same time you need to consider this one. So last time we confused about the control, but this time the control contains R and S is okay. We can easily differentiate this one. But in the when we were using another data, so the control name was PN something like this. So the int there is R and there is S. So the in PCA in this figure the R and S were not included. So we were confused that this control is belong to R or this one is belong to soil. So at that time you need to consider this one. And I think it's almost completed. So you can use this one from here. It's up to you. If you are not going to use this one, so let me close this one. Same thing, you need to go here, export Excel file and upload your data. Try to use the same one. Next. This is the same one, but I want to tell you which ordination you have to use. It's up to you. So this is the plot name and phylum name. Even though we have selected the full length unlimited, so here is also mentioned, but in the figure you can see that only 8 characters are included. Even though there is an option 8 character, short up to 8 character, but here we mentioned the full name, but in the plot there is not full name. So you need to do manually by yourself. So go here, and the sub one is E and B. This one is almost same one. So in this case, suppose we can say that the environmental variable names shorter up to 8 character only. It's okay. If in this case the names are shorter, then we can say that the only 8 characters here. But for environmental variables, it's okay. Need to go finish. And here, last time we did this one. From initially, if your purpose is to do the constraint analysis, don't choose the unconstrained. So you are all these things we did in the new section here, but from here you can choose anyone. If your purpose is to do the constraint, if your purpose is constraint, on select only one variable, it's up to you. So suppose this one we have done, even though within the same, using the same data, we also did all these three. So then okay, the RDA, now right now we are going to use the CCA. So if you want to transform your data, so it's up to you. You can use two constraint axis like this. It's up to you if you are not going to use this one. Second, data transformation is up to you. If you use log, this one square root or like this. So if you are going to use log, then definitely data will be, the figure will be different. If you are not going this one, definitely the data will be different. So right now the same parameters if you want to use. Yeah, this one. This is CCA, so yeah, you can see that here they even mentioned the symbols here. So it's up to you if you want to use this or not. It's up to you. So the second graph is almost the same in the previous one. The method of using your data and to generate different ordination is same, but you need to know when I have to use PCA, PCOA, RDA, CCA. It's depend on your data. So this time we use the CCA, but this just only difference is that here for each phylum you can see that there is a special symbol. So almost this is same, but the distribution, the environmental variables indication will be different for each ordination. So you need to learn the difference between these 4 or 5 ordination. Even though the data importation and analysis method is same for everyone. After I told you two way. One is first time you need to import your data into the Kineko. After doing any one analysis like this one, you can use another analysis by using this one. So it's up to you which one you have to use. So for time being, I think I know these kinds of information from Kineko. If you have other if you get any information or other things about Kineko, you can use by yourself. Till now, I know these things in Kineko. So for tomorrow meeting, definitely you can use any data to show the PCA, CCA, RDA, and PCO, any kind of data you can use and generate same figure.
But we don't have time.
It's okay. Anytime. It's
We need
okay.
to get.
It's okay. No problem. Anytime you can.
Just make
practice.
sure professor can know this thing that you can do this one. That's it.
Yes, almost. It's not difficult one. It's